Hello, am I audible? Okay. Okay. So here we are developing one more approach to analyze the transient, and that approach is known as Laplace transform. So how Laplace transform? How Laplace transform? How Laplace transform is solving this differential equations, because Laplace transform is a tool which converts your differential equation into algebraic equation. So it is rather easy to deal with the algebra rather than differential equation. But you can solve all the questions with both of the approach. Means there is no choices. You can go by Laplace or you can go by differential equation. But differential equation is the easy thing, because we don't have to convert it into the Laplace and then come back to the again time domain. Differential equation is direct solutions are available. You can write the solution of that equations. So here after developing that logic, we are solving few problems on the based on the Laplace transform, which we have solved using the differential equation case also. और उन प्रॉब्लम्स को सॉल्व करते हुए अब हम आगे बढ़ेंगे, कुछ और प्रॉब्लम्स को हम देखेंगे, प्रैक्टिस करेंगे, कुछ PYQs भी हैं उनको भी हम देखते हैं. जरा आगे चले. ये क्वेश्चंस जो हमने अभी कर लिए थे पिछले सेशन में, थोड़ा और आगे चल के कुछ और क्वेश्चंस को देखते हैं. एक क्वेश्चन है मेरे पास. I have one question, and what this question is saying, a square pulse of 3 volt amplitude is applied to RC circuit. ये एक RC सर्किट है, जैसा कि आप जानते हैं. दिस इज रेजिस्टेंस, you are taking output across this resistance. So this is high pass filter kind of circuit. The capacitor initially is uncharged and the output voltage V2 at t equal to 2 seconds. So we are interested in the output voltage at t equal to 2 seconds. Okay. If capacitor's initial condition is 0, I can directly take the Laplace transform of the circuit. So what is the first step? Our steps are very common. First, take the Laplace transform of the circuit with initial condition, that keep in mind. First, take Laplace transform of the circuit. And what is the second task? Second task is to calculate the desired variable. What is third task? Third task is to find inverse Laplace transform, and then you can write the answer. So here we are having one circuit. How circuit is given? A circuit is given like this. C, one resistance is given. They are calling this value as R. One value is C, another value is R. And what is input voltage? Input is given as VI, and VI is a square kind of pulse. So here I am writing this as VI. Correct? And what is output? Output is V out. This is our circuit. What is the first task? While solving the question using Laplace transform, first take the Laplace transform of the circuit. So when I take the Laplace transform of this circuit, how this circuit will looks like? When all initial conditions are 0, the Laplace transform will be very easier. So you can say this is one capacitor, and I will replace my capacitor by 1 by S into C plus initial voltage, but initial voltage in that case is 0. So one resistor with the series with voltage source, and that voltage is equivalent to 0. What next? Next we are having one resistance R. So here we are having one resistance R, and this is our VI. I am calling this potential as VI, and this is our V out. So VI is also given in S domain, and V out is also given in S domain. VI and V out both are given in which domain? Both are given in S domain. This is V out of S. This is your circuit which is available in which domain? This is our circuit which is available in Laplace domain. This is Laplace transform of the circuit, and initial conditions are 0. If initial conditions are 0, then you don't have to add this additional voltage source. Now what I can say that we can apply the KVL. What is the third step? Third step is to apply KVL in the circuit. So when I apply KVL in the circuit, this is VI, or let me call this potential as VI of S. Whatever available to us, I will take VI of S. Then we are having 1 divided by SC. Then we are having R, and this value I am calling V output of S. Now what is the value V output of S? The value of V output of S, we can have current inside this. So let's say current inside the circuit is equivalent to I of S. अगर सर्किट के अंदर का करंट I of S हुआ, तो लाप्लास डोमेन में जो करंट का वैल्यू होगा I of S, that is equivalent to what? Vi of S divided by, two resistances are there. One resistance is frequency dependent resistance, we can call it 1 by SC, and another value we can call R. Correct? Now I am interested in output value. So what is output? The output is given by V output of S is given by 1 R multiplied by current I of S. R का जब I of S से multiply करूंगा तो कितना हो जाएगा? RCS divided by 1 plus RCS. R है, ये CS का multiply किया 1 plus RCS, and this is RCS multiplied by what? VI of S, and this value is equivalent to V output of S. So what is first step? First step is to take Laplace transform of the circuit. What is second step? Second step is calculate that variable. So which variable is needed? The needed variable is this V2. We want V2 or V out. So V2 we are interested in. We are interested in V out. And what is VI? VI is given as a square pulse of width 2 seconds. How I can write this square pulse? I can write my VI like this. VI can be written as what is magnitude? Magnitude is 3. So you can write this function as 3 times of ut. So you will get a 3 unit jump, and after 2 seconds you have to bring it to the 0. So you can write minus 3 times of ut minus 2 seconds. And if I take Laplace transform of this, Laplace transform of this waveform will be 3 divided by S minus 3 divided by S into e to the power minus of 2S into e to the power minus of 2 into S. Correct? Now I will put this value in our equation. So can I say our equation will be V output of S is given by 3 divided by S into 1 divided minus 2S. What is this value? This value, when you take Laplace transform, here I am using the shifting property. So it is shifted by 2, so e to the power minus 2S will appear here. Fine. And what else we are having? We are having multiplied by this expression, RCS divided by 1 plus RCS. So can I say here we are having RCS divided by 1 plus R into C into S. Correct? This is the output in S domain. What is cancel? This 3 S and S is cancelled. So this value is what? This value is 3 times of 1 minus e to the power minus of 2S into RC divided by RCS. Now we know the value of RC. What is the value of RC? So RC product is given in the question and RC product का जो value होगा वो कितना होगा? RC product of this system is R equal to 1 kilo ohm, and 1 kilo ohm is nothing but 10 raised to the power 3 and 0.1 farad. So 0.1 into 10 raised to the power minus of 6. So this is 10 raised to the power minus of 4. The value of RC is 10 raised to the power minus of 4. Now can I say, if I write the inverse Laplace, because once you know this expression, we are only interested in inverse Laplace now. And inverse Laplace is available for this kind of function. When you are having this kind of function, inverse Laplace transform of 1 divided by s plus a, this kind of functions are available, then in this case we can write the inverse Laplace transform of this function is e to the power minus at for t greater than 0, or you can write this as a ut. Correct? This type of functions. So here we are having RC and here we are having RC, so you can say this is s, this is this value. How I can write it? RC cancel, so this is 1 divided by 1 by RC plus S. Or you can say my original expression will looks like this. This is 3 times of 1 into e to the power minus of 2s into 1 divided by RC. As you know that the value of RC is 10 raised to the power minus 4. So 1 divided by RC is 10 raised to the power 4. So you can say this is 1 divided by s plus 10 raised to the power. This is our original expression. You can take this 3 out. So how much you can write? This you can write 1 divided by s plus 10 raised to the power 4. If I multiply this value here, and you can multiply it by 3 also, no issue. You can cancel this 3. Fine. Minus we are having minus 3 times of e to the power minus of 2s, and again we are having the same expression. Now I will use which property? I will use shifting property. So what is inverse Laplace transform of this function? When I calculate the inverse Laplace of transform of this function, this is 3 into e to the power minus of 10 raised to the power 4 into t. Correct? E to the power minus at. So what is value of a? Value of a is 10 raised to the power 4. So, and this expression is valid only for t greater than or equal to 0. Always remember, this expression belongs to that category. But when you look at the second expression, what is the inverse Laplace transform of this? E to the power, I can write this inverse Laplace minus of 3 e to the power minus of 10 raised to the power 4 into t, or let me write, if I write this, it's better to write with the ut. So this is what? 3 into e to the power minus 10 raised to the power 4 into t into ut, and this expression is what? This expression is minus of 3 into e to the power minus 10 raised to the power 4 into t. Now you have to focus on this t. Our Laplace domain expression is multiplied by e to the power minus 2s. You know that it is 1-to-1 mapping. So x of t minus 2, if this is having Laplace transform of x of e to the power minus of 2s, then when you go back to the time domain, this will gives you t to the t minus 2. This effect is only because of delay. So you can write this value will be, let me use different pen. This value will be what? This value will be, this value will be t minus 2, and I can write this value as u of t minus 2. Correct? This is the expression. Now what they are asking, when you go to the question, they are asking जो आंसर क्वेश्चन पूछा गया है वो बोला गया कि 2 सेकंड पे कितना वैल्यू होगा, चलो देखते हैं 2 सेकंड पे कितना वैल्यू होगा। 2 सेकंड पे जो वैल्यू होगा वो इतना होगा कि हमारे पास जो वोल्टेज का आंसर आया है V2t है, जिसको हमने V आउटपुट ऑफ t बोला है, दैट वैल्यू इज इक्वलेंट टू 3 इंटू e टू द पावर माइनस 10 रेज़्ड टू द पावर 4t into u of t, and what is this value? This value is minus 3 into e to the power minus 10 raised to the power 4, और हमारे पास एक फंक्शन का मल्टीप्लाई किया है e to the power minus of 2s. Because of multiplication of this function, everything is shifted by 2 units, so this is u of t minus 2. This is u of t minus 2. Correct. Now we are interested in this voltage at t equal to 2 seconds. So V2 at t equal to 2 seconds is given by 3 e to the power minus of 2 into 10 raised to the power 4, and 2 raised to the power 4 means it is e to the power minus of 20,000 into u of 2, because we will replace every t by 2, minus this value is, if you put t equal to 2, this value will be 0, so e to the power 0, and this will be u of 0. Correct. Now this is 3 divided by, what is the value of e? 2.3. so 3 divided by 2.3 to the power 20,000, so you can say this value will be what? Approximately 0. So what is correct answer? Minus 3 into e to the power 0 u of 0. That value is equivalent to what? Minus 3 volts. So correct answer for this question, correct answer for this question is what? Correct answer for this question is minus of 3 volt. Minus 3 volt is correct answer for the given question. Okay, we have one more question based on Laplace. You can, what is this? The figure shown below, assume that all the capacitors are initially uncharged, means there is no initial value of this capacitor. If Vi equal to 10 times of ut, do we know that if Vi is equivalent to 10 times of ut, so इस सर्किट से जो हमसे उम्मीद की जा रही है वो स्टेप रिस्पॉन्स निकालने के लिए बोल रहा है. सो यू कैन से Vi of s equal to what? Vi of s equal to 10 divided by s. It is given. Okay, so what is the output of this? How we can proceed for this circuit? So let's say I am assuming this branch as my impedance Z1. Let's simplify it. I am saying this branch is what? I am calling this Z1. And I am calling another branch, this branch as Z2. तो हमारे पास जो सर्किट हुआ ये तो एक पोटेंशियल डिवाइडर सर्किट हुआ, एक है Z2 और एक है Z1. अगर एक पोटेंशियल डिवाइडर सर्किट है, और आसान इसलिए भी है क्योंकि सारी इनिशियल कंडीशन 0 है, तो ज़्यादा लेंदी नहीं है. तो देखें ज़रा हमारे पास जो नेटवर्क अवेलेबल है वो कैसा है. द नेटवर्क विच इज अवेलेबल टू अस in time domain is this. We are calling this as a Z1. We are calling this as a Z2. और सारी इनिशियल कंडीशन 0 है, और सारी अगर इनिशियल कंडीशन 0 है तो यू कैन अज्यूम दैट दिस इज द फ्रीक्वेंसी डिपेंडेंट रेजिस्टेंस, एंड दिस वैल्यू इज व्हाट? दिस वैल्यू इज this value is V. What is the next step? So you are having the circuit in the time domain. What is next step? Next step is we are interested in the circuit in frequency domain, in Laplace domain. So what is circuit in the Laplace domain? Just replace this by S. If you write Z1S, Z2S, V out will be S, and this is also S. Correct? Now can we say what will be the current in the circuit? The current in the circuit is, let's say I am taking current as I of S. तो यहाँ जो I of S का वैल्यू होगा वो कितना होगा? I of S का वैल्यू हो जाएगा हमारे पास Vi of S divided by Z1 of S plus Z2 of S. But we are interested in the output voltage, and output voltage of this is given by V output of S is given by Z2 of S divided by Z1 of S plus Z2 of S into VI of S. This is our final expression. तो अब मुझे किसकी रिक्वायरमेंट है? अब मुझे Z1 Z2 की रिक्वायरमेंट है, और जैसे ही Z1 Z2 का वैल्यू पता कर लेंगे, I will be able to calculate the answer. So first we have found that variable, and now we will take inverse Laplace transform of that variable. Now what is the value of Z1 and Z2? Can I say here the parallel combination of R and C? So you can say if initial conditions are 0, Z1 can be written as R into 1 by CS divided by R plus 1 by CS. कि जब दोनों रेजिस्टेंस ही है तो दो रेजिस्टेंस का पैरेलल कितना होता है? इतना. तो दिस वैल्यू विल बी R डिवाइडेड बाय RCS प्लस 1. करेक्ट. एंड इसके लिए भी इतना ही. तो अगर मैं Z1 की वैल्यू, क्योंकि यहां भी एक रेजिस्टेंस और एक कैपेसिटेंस पैरेलल है, यहां भी एक रेजिस्टेंस और कैपेसिटेंस पैरेलल है. सो फर्स्ट केस, व्हाट इज R? R is, let's say R is 1 kilo, and what is RC? RC is 4 into 10 raised to the power minus of 6 into 10 raised to the power minus plus 3. This value will be 4 into 10 raised to the power minus 3. 4 into 10 raised to the power minus 3 S plus 1. This is our Z1. What is Z2? तो Z2 के लिए भी एक्सप्रेशन में कोई चेंज नहीं आएगा, क्योंकि यहां भी एक कैपेसिटर और रेजिस्टर पैरेलल में है. तो हम इसको देख लेते हैं. Z2 का वैल्यू हो जाएगा, R की जगह अब मैं वैल्यू लिख दूंगा कितना, 4 किलो डिवाइडेड बाय, यहां RC का वैल्यू कितना है, 4 किलो और 1 माइक्रोफेरेड. सो 4 किलो इज 4 into 10 raised to the power 3. 1 microfarad is 1 into 10 raised to the power minus of 6, and this value is nothing but RC. तो RC का वैल्यू हुआ 4 into 10 raised to the power minus 3. ओके, प्रीवियस जैसा ही है. तो डिनोमिनेटर दोनों का सेम है, 4 into 10 raised to the power minus 3 into S plus 1, and denominator is same for both. So can I say what is your first thing you want? The first thing you want is Z2. So what is value of Z2? Z2 is having value 4. This value is 4, and denominator common है, तो I will write denominator as D. So 4 divided by D divided by, denominator is common, और कॉमन होगा तो उसको लास्ट में लिख देंगे. What is Z1 and Z2? So 1 divided by D and 4 divided by T. 1 divided by D plus 4 divided by D, this value will be 5 divided by D into VI of S equal to V out of S. ये वैल्यू कितना हो जाएगा, 4 divided by D and D divided 4 by 5 times of VI of S. What is VI of S? Input. What is input? Input here is 10 times of ut, और 10 times of ut का लाप्लास ट्रांसफॉर्म होगा 10 by s. So can I say the VI of S is 10 divided by S. This value is V output of S. So we have come to the point where we'll know what is the output voltage. So this is 5 into 2, cancel. This value is 8 divided by S equal to V out of S. अगर हम ये जानते हैं कि 1 का जो 1 by S का इनवर्स लाप्लास ट्रांसफॉर्म ut होता है, तो 8 का कितना होगा, 8 times of ut. If we know the inverse Laplace transform of 1 by S, if we know the inverse Laplace transform of 1 by S, if we know the inverse Laplace transform of 1 by S is u of t, then what is Laplace transform of 8 by S? 8 by S, because this is linear transformation, so multiply both side by 8. This will be what? 8 times of ut. So what is correct answer? The output voltage is given by 8 times of ut. Here we are having V output equal to what? 8 times of ut. So you can go to the question and can answer it. 8 times of ut. This is correct answer for the given question. I hope this is clear. Let's go to the next question. All questions are based on which theory? All questions are based on Laplace theory. When you go to the next question, what next question is saying? In the following figure, C1 and C2 are two ideal capacitors. C1 has been charged to 12 volt before the ideal switch S is closed, the T equal to 0. Okay, so we are having one charged capacitor and one uncharged capacitor. And one charge C1 is charged to the 12 volt. So how to do this? First we are having the circuit. So how to solve this circuit? First take the Laplace transform of the whole circuit. So can I say we are having this circuit for t greater than 0 will looks like this. Circuit for t greater than or equal to 0 will how it will looks like? It will looks like this. C1, what is the C1? This value is C1. Let me call this value is C1. What about capacitor? What about switch? So switch is closed now. So can I say the switch is closed now? Switch is closed now means this. And what is next? We are having C2. So this is your capacitor, C1 and C2. What they are asking? They are asking the nature of current. Okay, let's calculate the current in this. So what is the first step? First step is to take Laplace transform of this circuit. First step is to take Laplace transform of this circuit. First step is to take Laplace transform of this circuit. So when I take the Laplace transform of the circuit, how the circuit will looks like? तो जो सर्किट दिखेगा वो कैसा दिखेगा कि पहले के पास कुछ इनिशियल कंडीशन है, दूसरे के पास कोई इनिशियल कंडीशन नहीं है. तो जिसके पास इनिशियल कंडीशन नहीं है उसको तो हम 1/s into c कर देंगे, पहले का इक्विवेलेंट लिखते हैं. सो दिस इज द सर्किट इन द लाप्लास डोमेन. दिस वैल्यू इज 1 divided by s into c1 and this value is plus minus. How much? We are having initial voltage equal to what? 12 volt. So if this is 12 volt, we will write 12 by S. This is the equivalent of capacitor number 1. What next you are having? The next you are having the capacitor number 2. And how capacitor number 2 will looks like? Capacitor number 2 is just uncharged capacitor, and uncharged capacitor means this initial voltage is 0. So I can say capacitor 2 will looks like this. One divided by S into C. Correct? We have taken the Laplace transform of the circuit. Once the Laplace transform of the circuit is available, we can find the current in the circuit. So what is current in the circuit? You can write, you are having current in this direction. And this current is I of S. So let's write the KVL for this. So can I say the KVL for the circuit is given by, how you will write the KVL? KVL of the circuit is given by minus 12 by S. So I can write 12 by S is equivalent to what? This potential plus this potential. Do we know what is the polarity of potential here? The polarity of the potential here is this. This is plus, this is minus, because current is entering in from this direction. This value is, I can write this potential here, I of S divided by S into C1. And this current will enter here. So this polarity will be I of S divided by S into C. So when we are completing the root, we are going plus to minus and plus to minus. So you can say this value will be what? This value will be what? I of S 1 divided by S into C1 plus 1 divided by S into C. This is the value of what? This is the value of the multiplicand of I of S. Now we can cancel this S. 1 by S is here, 1 by S is here, and 1 by S is here also. We can cancel it. So what is value of I of S? 12 divided by 1 divided by C1 plus 1 divided by C2. This is value of I of S. आपसे पूछा है कि what is the nature of current? तो nature of current बताने के लिए what is the first step? First step, we have taken the Laplace transform of the circuit. If Laplace transform of the circuit is known, what is the second step? In second step, we are interested in the inverse Laplace transform. तो हमें ये पता है कि कोई नंबर, ये this whole number is what? C1 and C2 are constant, so whole number is constant. So do we know what is the Laplace transform of impulse? Laplace transform of impulse is 1. Correct? So what is inverse Laplace of 1? Inverse Laplace of 1 is delta t. Inverse Laplace transform of 1 is equivalent to what? Delta t. I am also interested in the inverse Laplace transform. So I am multiplying my input. फूरियर ट्रांसफॉर्म हो या लाप्लास ट्रांसफॉर्म हो या जेड ट्रांसफॉर्म हो, स्केलिंग प्रॉपर्टी को सभी सेटिस्फाई करेंगे कांस्टेंट से. अगर आपने इनपुट को मल्टीप्लाई किया है, 1 को मल्टीप्लाई किया है 12 डिवाइडेड बाय 1 डिवाइडेड बाय C1 प्लस 1 डिवाइडेड बाय C2 से, देन यू कैन मल्टीप्लाई डेल्टा टी मल्टीप्लाइड बाय व्हाट? एंड व्हाट इज मीनिंग ऑफ दिस? If your output is multiplied by delta t, impulse times of something, there is no meaning of this constant. So what I am saying, what is the nature of current? So nature of current in time domain is this. Which nature? Impulsive nature. Because impulse is infinite at t equal to 0, at the rest of the places it is 0. So when infinite is multiplied by this number, everything is impulsive. So what is nature of current in the circuit? The nature of current in the circuit is impulse function. Nature of the current in the circuit is what? Impulse function is correct answer. So IT is given by by 12 C1 C2 divided by C1 plus C2 into delta t. This is the final expression. So if they ask the expression, we can get the expression, or this value is also true. Let's go to the next. What is next question? Next question in the circuit, in the Laplace transform is this. Okay, let's take one more question. And what this question is saying, the network of the figure is a steady state with the switch K is open. When switch K is open, the network has achieved the steady state. The switch K is closed, IT for numerical value given. Is K is the current waveform and indicate the value of constant. Okay. What this question is saying, the circuit has reached to steady state with switch K is open. Okay. So this must be the direction of the switch. The switching direction is different. What is initial switch position? Initially switch was open and then it was closed. So a switch is given, and whenever a switch is given in the circuit, we are interested in the initial value. In this question, the initial value also you have to calculate. So what is initial value? You can calculate the initial value. This point is, this is the switch position number 1. This is the starting point, t equal to minus infinite, and it comes to the t equal to 0 minus. So t equal to 0 minus will be the steady state position when switch was open. open switch, and when switch is closed, when switch is closed, we are interested in the response at this point, value of IT8 for closed switch. So when switch was open, this circuit is needed? When switch was open, the circuit has achieved the steady state. Always remember, this is our circuit. Initial position of the switch was open. So circuit has achieved the steady state. So 20 plus 30, 20 plus 10 is 30. So this is the initial condition, in steady state. At t equal to 0 minus, how our circuit looks like? 10 plus 20 is 30, because initially switch is open, because this is given. In the network reaches the steady state with switch K is open and t equal to 0, the switch is closed. So we know that at t equal to 0, the switch is moving from open to close. So when switch is open, there is no meaning of the switch. Can I say this 20 and 30 ohm in series will gives you 50 ohm? And how your capacitor will behave in steady state? Inductor will behave in steady state, short circuit. So what is the current? The current IL0 minus, 3 by 5. 30 by 50 is what? 3 by 5. And you can copy this current here. This is the only thing we need from this circuit. So whenever they will give you switch, they will not give you initial condition. If initial condition is given, there is no meaning of switch. So IL0 plus equal to what? 3 by 5. Now at t greater than 0, switch is closed. So how? Let me draw the circuit for t greater than 0. Can I say if switch is closed, there is no meaning of this. The 20 volt will drop across 30 ohm. So there is no meaning of this path. So can I say we are having for t greater than 0, this value is 10 volt. Then we are having 20 ohm. Why it is 20 directly I am writing? Because there is no meaning of this. When you talk about this path, if switch is closed, this 20 volt will drop across this. No current will come out from this. So 20 ohm, and then we are having what? Inductor. And inductor value is 1 by 2 half Henry. Once you know the circuit for t greater than 0, what is the next step? This circuit is available. Let's take the Laplace transform of this circuit. So if I take the Laplace transform of the circuit, how circuit will looks like? This 10 will be what? This 10 will be 10 divided by S. Correct? What is the value of 20? So this is one resistor and it is not dependent on the S. So this value will be 20. What is this value? This value is equivalent to 20 ohm. What is next? Next we are having inductor. और इंडक्टर की कुछ इनिशियल कंडीशंस भी हैं. तो क्या करना पड़ेगा? इंडक्टर को सबसे पहले मैं लगाता हूं यहां. And value of inductor is what? S divided by 2. Why S divided by 2? Because L into S. So L is 1 by 2 and S is variable of Laplace. Then we are having negative, positive. How much? L into I0 minus. So what is L? L is 1 by 2 and I0 minus is 3 by 5. So 3 by 5 into 1 by 2, which is equivalent to 3 by 10. This is our whole circuit. This is the circuit which is available in which domain? This is the circuit which is available in the Laplace domain. This is the circuit which is available in which domain? This is the circuit which is available in the Laplace domain. If this circuit is available in the Laplace domain, and which direction you need current? You need current in this direction. So can I say here my current will be what? here current will be I of S. If this current is I of S, I can apply the KVL here. So let's apply the KVL. Let's apply the KVL to the circuit. If I apply the KVL to the circuit, how circuit will looks like? This potential drop is 20 into I of S, and current will enter from the positive polarity. So this is S by 2. So S by 2 into S by 2 into I of S. So this is I of S divided I of S into S divided by 2. We know the potential across every component, so you can say this value is, or you can direct write the potential difference divided by resistance is the current. So you can say, what is potential difference? Potential difference is, you can write current as potential difference. And what is potential difference? Higher potential is 10 by S and lower potential is minus 3 by 10. So you can say, we can say 10 by S minus 3 by 10 divided by how much? Divided by, we are having 20 plus S plus 2. 20 plus S plus 2. And this value will be what? This value will be 100 minus of 3S minus 3S 100. And what is denominator? Denominator is 10S. 10S is what? 40 plus S divided by 2. So if you divide it by 2, this 2 and this 10 is cancelled. So this value is 5. 100 minus 3S divided by, and how we can write this value? We can write this I of S as, well, let's write both terms separately. So here we can write 100 divided by 5 is 20. 100 divided by 5 is 20. So we can write this as a 20 divided by S into S plus 40. S plus 40. And what else? Minus 3. S is cancelled. So minus 3 by 5. Minus 3 divided by 5. And this value is what? S plus 40. Because S and S cancel, so S plus 40. Correct? Now how I can write it? I can take 20 as common. If I take 20 as common, I can write this as a 1 by S minus 1 divided by S plus 40. So when you solve this, this will be S plus 40 minus S. So 40 is on numerator. And what we are having? We don't have 40 on the numerator, so I will divide it by 40. Correct? And this value is minus 3 by 5, 1 divided by S plus 40. Now I can take the inverse Laplace transform. And what will be the inverse Laplace transform? The inverse Laplace transform of 20 by 40 is 1 by 2. What is inverse Laplace transform of 1 by S? It is u of t minus e to the power minus of 40 into t into u of t minus 3 by 5 is minus 0.6 into e to the power minus of 40 t into u of t. Let's write each term together. If I say I can take ut as common, or let's write the solution of it for t greater than 0. It for t greater than 0. How it will looks like? 0.5. 0.5 into ut. So I am taking ut out from this. 0.5. What else? This is minus 0.5 and this is minus 0.6. Okay, we made one mistake here. It is plus. Here it is also plus, because we are writing higher potential minus lower potential. So higher potential minus lower potential will be plus sign here. If you are using plus sign here, plus sign is also here. And if you are using plus sign here, this will be plus, this will be plus. This is minus 0.5 and this is plus 0.6. Minus 0.5 plus 0.6 is 0.1. 0.1 into e to the power minus of 40t. So what is the behavior of minus 0.5 plus 0.6? 0.5 plus 0.6 is 0.1 into 40t. This is the equation. So they are saying us to draw the IT. So how we can draw the IT? What are 2 points? 2 points are 0.5 and 0.6. And what is next point? This value is 0.5. This value is 0.6. So what is the value at t equal to 0? The t equal to 0, this value is 0.6 ampere. And when t is approaching to infinite, this value will reach at 0.5 ampere. So this is the idea of current inside the inductor. And you can check also, what is the final current? Final current is this, 10 by 5. What is, we can check the answer, how this circuit will behave in a steady state. This inductor will be short circuited, so 10 divided by 20. 10 divided by 20 is 0.5 ampere. So you know that in steady state, what is the current? In steady state, the current is 0.5 and initial current is 0.6. So fine. You can write, you can solve the same question by using what? Laplace approach also. You don't need to perform anything, just write the equation, you will get answer. Okay, one more question based on the Laplace transform. Which type of circuit is given? One RLC circuit is given. One RLC circuit is given. Following series RLC circuit with the zero initial condition is excited by unit impulse. So just they are asking the unit impulse response for this circuit, and these are the values. What will be the voltage across capacitor? Always remember, in this type of circuit, there is no initial condition given. If no initial condition is given, you can directly take the Laplace transform. So what is Laplace transform of 1? So you can delta t, the Laplace transform of delta t is 1. What is Laplace transform of inductor? You can say the Laplace transform of inductor is S. What is Laplace transform of resistor? This value is 1. And this is multiplied by what? 1 divided by S. And they are calling this value as what? They are calling this value as VC of S. So they are interested in what? They are interested in the VC of S only. What is the value of VC of S? VC of T. So you can use the Laplace transform to solve this. What is current inside the network? If I had say this current is I of S, what is the value of I of S? The value of I of S for the circuit is given by, the value of I of S for the circuit is given by what? 1 divided by S plus 1 by S plus 1. You can see here we are having inductor S plus 1 by S. This is the value of IS, and IS can be written as S divided by S square plus S plus 1. But we are not interested in I of S. We are interested in what? We are interested in VC of S. So VC of S can be written as 1 by S resistance times of current. And what is value of current? Here the value of current is S divided by S square plus S plus 1. These two variables are cancelled. So what is answer? Answer here is 1 divided by. So we have followed our all step. What is the first step? First step is to take Laplace transform of the network. What is second step? Get variable of that, get the answer for that variable. Now we have to convert this variable into the inverse Laplace transform. So can I say Vc of S is written as 1 divided by S square plus S plus 1. Because we don't have the inverse Laplace for any quadratic equation, so let's make it the perfect square. So if I make this as a perfect square, this value will be what? S. मिडिल टर्म का हाफ करें और उसका स्क्वायर जोड़ दे घटा दे, तो दिस विल बी S प्लस 1/4 minus 1/4 plus 1. So that we can make it perfect square. So Vc of S का जो वैल्यू होगा वो वैल्यू कितना हो जाएगा? This value will be 1 divided by how much? S plus 1/2 whole square. S plus 1/2 whole square, and this value is what? 1 minus 1/4 is 3/4. So under root of 3 divided by 2 square. This is sine kind of expression. S square plus A square, A divided by. So what is missing? A is missing. So let me multiply it by under root of 3 divided by 2 and 2 divided by under root of 3. You can multiply any expression by a constant. So you can say this value is what? A divided by S square plus A square plus with one shift is also given. So can I say this value will be what? Sine of, when I take the inverse Laplace transform, this is nothing but sine of under root of 3 divided by 2 into t. Now this is shifted into ut. Now we are having shifting of e to the power s plus 1/2. So s plus 1/2 can be written as e to the power minus of t by 2. Correct? And what is magnitude? 2 by under root of 3. So this question is generally a question of inverse Laplace transform. So what I can say? Okay. 2 by under root of 3. What is the value? 2 by under root of 3 e to the power minus 2 sine. So this value is correct. This value is correct. So this question belongs to the category. This question belongs to the category where inverse Laplace transform is needed for the question. Let's go to the next. They are saying that what is the value of voltage across resistor? Okay, they want the voltage across this. Can I say, if we are interested in the voltage across this, the current of the circuit is what? Already known. It is S divided by S square plus 1 plus S. And they are saying that what is the voltage across resistor? So voltage across resistor is what? Voltage across resistor in S domain is 1 into I of S, and 1 into I of S is still I of S. So we are interested in the inverse Laplace transform of this variable. We can easily find the inverse Laplace of this. S divided by, what is denominator? S plus 1/2 whole square plus under root of 3 by 2 whole square. This is the equation we are having. Now, do we know that this is VR, the voltage across resistor in S domain? Do we know that S divided by S square plus A square is what? Cosine of under root of 3 divided by 2 into t. S divided by S square plus A square. Now we are having shifting of e to the 1/2, so I can write this as a e to the power minus of t by 2. And this value is what? Easy question. So this question, nothing network is used, only which part is used? Inverse Laplace transform is used for this question. Okay, next question. For an RL circuit shown in the figure, the input voltage is VIT equal to UT. Unit step response they are asking for this, and which waveform is correct? I think very simple question. Let's take the Laplace transform of this circuit. If I take the Laplace transform of this circuit, this value will be what? This value will be L into S. So this value will be S, this value will be 2. And what is current? Current is 1 by S. So can I say the current I of S will be given by supply voltage. What is supply? Supply is 1 by S because U of T is connected here, divided by resistance. So voltage, applied voltage divided by resistance is S plus 2. So I can say I of S is equivalent to what? 1 divided by, this value is what? 1 divided by S into S plus 2. जब इसको लिखूंगा मैं पार्शियल फ्रैक्शन से, तो दिस इज 1 by 2 टाइम्स ऑफ 1 by S माइनस 1 डिवाइडेड बाय S प्लस 2. और ये वैल्यू कितना हो जाएगा? अगर इसका इनवर्स लाप्लास ट्रांसफॉर्म लिया जाए तो IT इज इक्वलेंट टू 1 by 2 into 1 minus e to the power minus of 2t into ut. So response is 0 for t less than 0. What is the response at t equal to 0? t equal to 0 पे वैल्यू है इसका 0. तो चारों का t equal to 0 पे इसका वैल्यू कितना है? 0. What is the value at t equal to infinite? t equal to infinite पे वैल्यू है इसका हाफ. तो ये हटा, या तो ये सही हो सकता है या ये सही हो. फिर आपसे बोल रहा है कि इसका टाइम कांस्टेंट कितना हुआ. तो टाइम कांस्टेंट के बारे में हम डिटेल डिस्कशन कर चुके हैं. द टाइम कांस्टेंट ऑफ दिस इज 1 by 2 second. The next 2t equal to 1. So this is 1 by 2 second. So you can say who is having the 1 by 2 second time constant? This is having 1 by 2 second time constant. So which option is correct? Option C is correct here. Which option is correct? Option C is correct here. This is 1 by 2 hidden. The 2 is there. Okay. One more circuit is given. In this circuit, what they are talking about? Okay. The switch S in the circuit has been closed for a long time. So switch S is closed for a long time. If switch S is closed, it will charge the inductor. Fine. And whenever we are having the second order circuit, means L and C are together. So generally our first idea to apply the Laplace in this type of circuit. So for a long time it is opened at t equal to 0 and remain open after that. Assume that the diode has 0 reverse current and 0 forward voltage drop. 0 forward voltage drop means when diode is forward biased, it will act as a short circuit, and when it is reverse biased, it is open circuited. So how our circuit will looks like? Can I say a switch is given, and whenever a switch is given, this circuit will works in two mode. What a switch is given means you have to calculate the initial conditions. Wait for a minute. If switch is there, this circuit will works in two mode. The first one is for t equal to minus infinite to t equal to 0 minus, this is the steady state point for the circuit when switch is closed. When switch is closed, can I say, when switch is closed, what is, this will charge this inductor. So what is the direction of current? When switch is closed, you can say, this is 10 volt. This inductor, this resistance is having value how much? 1 ohm. And this is connected to what? This is connected to short circuited. Correct? And what is next? Next thing is one diode is also connected to the circuit, but both the terminals of the diodes are connected to 0. Both the terminals of the diode is connected to 0. If both the terminals of diode is connected to 0, diode is reverse bias. So I can say the current across inductor is what? IL0 minus, this current is 10 ampere. IL0 minus is equivalent to what? IL0 minus is equivalent to 10 ampere. Now we will take, if this 10 ampere is the current, if this 10 ampere is the current in the circuit, what is the direction of this current? When I draw this circuit at T0 plus, the circuit will looks like this. This is the 10 ampere current. This is one capacitor. And this is diode. I will replace diode by open circuit because diode will allow current only from P to N. So if the direction of current is P to N, this will act as a short circuit. So can I say, if I take the Laplace transform of the circuit for t greater than 0, how it will looks like? So our circuit in the time domain is this. This is one millihenry inductor. This is 1 millihenry inductor. Then we are having one diode which is open circuited now. Or you can say this is one diode. Then what we are having? One capacitor. And what is value of capacitor? The value of capacitor here is 10 microfarad. What else is given? Okay, steady state voltage across the capacitor with this polarity. Fine. So when I take the Laplace transform of this circuit, we are having one inductor. So inductor is represented by L into S. This is in addition with, what is the initial value? Initial value is 10 ampere. So 10 ampere into L. L is 1 millihenry. So 10 into 10 raised to the power minus 3. I0 minus into L. So 10 into 10 raised to the power minus 3. And here we are having 1 by CS. Correct? In which direction we are interested in the current? Current can flow in this direction only because we are having diode here, and because initial current is 10 ampere, so diode will act as a short circuit. Because diode only allows current from which direction to which direction? From P terminal to N terminal. Now you can apply the KCL. What is KCL? You are having here 10 raised to the power minus 2. So I of S can be written as applied voltage. What is applied voltage? 10 raised to the power minus 2 divided by how much? Ls into 1 by plus 1 by Cs. Ls plus E of S. Ls plus Cs. So you can say this value is 10 raised to the power minus of 2 L into S divided by LCS square plus 1. Now what I can say? I can say that 10 raised to the power minus of 2. I can take LC as a common. So this will be what? 10 raised to the power minus 2 divided by into S divided by C. This value is what? S square plus 1 divided by under root of LC. Now we are having S divided by S square plus A square kind of expression, and this is constant 10 raised to the power minus 3 divided by, what is the value of capacitor? Capacitor is 10 microfarad. So 10 microfarad can be written as 10 raised to the power minus of 5. And remaining expression is what? S divided by S square plus 1 divided by under root of LC whole square. When I write this, this is 1000 times of sine of, sorry, not sine, S divided by S square plus A square is cosine of 1 divided by under root of LC into T. So we can calculate the magnitude, the voltage magnitude across the capacitor. I hope this is clear. Let's go to the next. Okay. Let me open one more PDF in which we will solve the question based on transient analysis. Wait for a minute. This is the final practice session for the transient. After this, I will start the two-port networks. These are all previous year questions. So we will use both the approaches now. With the Laplace, without Laplace, we will try to approach all the questions. Okay. Let's see this variety of question. In this question, in the circuit shown below, a step voltage of magnitude 5 volt is applied at node A at the time t equal to 0. If the capacitor has no change for the voltage for t less than 0, means t less than 0, 0 volt is applied. Then what is voltage at node P? What is voltage at node P at t equal to 6 seconds? So they are interested in the voltage at t equal to 6 microsecond. How we can approach this question? So there are two approaches. One is time domain approach, another is Laplace approach. You can use any. So I will use Laplace domain approach. Can I say what is the initial condition of the capacitor? Initial condition of the capacitor is 0. Initial condition of the capacitor is 0 means initial voltage is also equivalent to 0. If initial voltage is also equivalent to 0, I can directly apply Laplace transform. So what is network? If this potential is 0, here 5 volt. So what is Laplace transform of 5 volt? Circuit in the Laplace domain. We are having a potential of 5 by S at node 1. Let's write 5 by S. So what is potential of node 1? 5 by S. Here we are having one resistor. Here we are having one capacitor. This is connected to the ground. What else is there? A 3 kilo ohm resistance is there. And I will replace this capacitor by 1 by S. Correct? This kind of circuit is given. So they are interested in which potential? The voltage at node P. So voltage across capacitor is needed. So voltage across capacitor is what? Let's say this voltage is Vp of S. Let's apply the KCL. What KCL says? KCL says that Vp of S minus of 5 by S divided by how much? This value is 2 kilo. 2 kilo. What is next? Next is current in this branch. So what is current in this branch? This current is Vp of S divided by 1 divided by C of S. And what is current in this branch? The current in this branch is Vp of S divided by 3K. Take care of unit also. And this is what? This is the KCL. KCL at node P. This is our KCL at which point? This is the KCL at node P. So take Vp one side and remaining value one side, you will get the value answer for Vp. So if I take Vp common, what is I am having? 1 by 2K from here, and from here we are having C of S, and from here we are having 1 by 3K. This is equivalent to what? Minus 5 divided by 2 into S. Minus 5 divided by 2 into S. So opposite side this will be 5 divided by 2S. Now we can calculate the value of Vp. The value of Vp here is 1 by 2 plus 1 by 3 is 5 by 6. So you can say this value is 5 by 6. Value is what? 5 by 6K. What else we are having? Plus C of S. And this value is equivalent to what? 5 divided by 5 by 2, 2.5 S. Now when I solve this, 5 by 6, okay, fine. If I take C common from here, because how I can write this? Let's write all the values. This is Vp. This is S plus, if I take C common from here, it is 5 by 6 into 10 raised to the power 3, and this is divided by C. What is the value of C? Value of C is given as 5 nanofarad. So 5 into 10 raised to the power minus of 9. And if you are taking C common here, the C will appear here. This value will be what? 2.5 divided by 5 into 10 raised to the power minus of 9 into S. This is the idea of total. So we are interested in the inverse Laplace of P. So Vp can be written as S plus 5 and 5 cancel. This value is 10 raised to the power 6. 10 raised to the power 6. Vp divided by 2K, Vp divided by 1 plus Cs, Vp divided by 3K, and 5 divided by 2 into K. 5 divided by 2K. Okay, this value is in, this is 5 by 6 10 raised to the power minus 6. So this is plus 6, and here we are having, this value is also in K, so you can write here we are having 10 raised to the power 3. So this is 0.5 into 0.5 divided by 2.5 divided by 5 is 1 by 2, 0.5 into 10 raised to the power 6 S. So when I solve this circuit, how this circuit will looks like? Vp equal to 1 by 2, this value is 10 raised to the power 6 divided by S into S plus 10 raised to the power 6, which I can draw Vp equal to 1 by 2, this is 1 by S minus 1 divided by S plus 10 raised to the power 6. So 10 raised to the power 6 is also available. So you can say this is 1 by 2, 1 minus e to the power minus of 10 raised to the power 6 t. If I take t equal to how many microseconds? 1/6 is there. Let me write it again. This value will be what? 0.5 into 10 raised to the power 6 divided by s plus 10 raised to the power 6 divided by s into s. When I take inverse Laplace of this, I can write this value as 10 raised to the power 6 divided by 6. When I take the inverse Laplace, how inverse Laplace will looks like? 0.5 I can take common and 6 I can take common from here. Because when I write 1 by s minus 1 divided by s plus 10 raised to the power 6 divided by 6, then can I say when I solve this 10 raised to the power 6 divided by 6 is needed. So 6 is not there, so we will divide it by 6 and multiply it by 6. So this value is 0.5 into 6 is 3 into 1 minus e to the power minus 10 raised to the power 6 divided by 6 into t. If I take t equal to how much? If I take t equal to 6 microsecond, what will be the answer? The answer will be 3 into 1 minus e to the power minus 10 raised to the power 6 divided by 6 into 6 into 10 raised to the power minus 6. Okay, this value is equivalent to the time constant of this equation. 1 minus e to the power minus. What they are asking? They are asking the value t equal to 6. So what is value at t equal to 6? 1 minus e to the power minus 1. .63. 1.89 is correct answer. Okay, let's take few more questions. What these questions are trying to convey us. Okay, one more waveform based question. What this question is trying to tell us? This question is saying that the voltage Vt shown below applied to the circuit when Vt equal to 3 volt for t less than 0, that is given in the waveform, and there is abrupt change as t equal to 0, means it is working like a switch, and the waveform for t greater than 0 is 6 volt. The value of current It equal to 1 second. What is the value of current at 1 second? So can I say t less than 0 circuit will provide such the initial condition, because every position of the switch is a stable position. If every position of the switch is a stable position, circuit has started from t equal to minus infinite. So t equal to 0 minus is one steady state point. And how circuit will behave in steady state? So you are having 3 volt here. You are having, what is the voltage at t less than 0? It is 3 volt. This is 1 ohm. This is also 1 ohm. This is also 1 ohm. And this inductor will act as a short circuit. If inductor will act as a short circuit, this resistance is also 1 ohm. One ohm. This is the circuit at T0 minus, and we are interested in the current stored by the inductor. So can I say the current stored by inductor is given by 1, because these two resistances are having same starting and same ending point. At same starting and same ending point, you can say the equivalent resistance of 1 and 1 is half. Half plus 1 is 3 by 2. So R equivalent of the network is 3 by 2. What is applied voltage? Applied voltage is 3. So current in the circuit is 3 divided by 3 by 2. So current is equivalent to 2 ampere. So source is drawing how much current? 2 ampere. And 2 ampere will be divided into two equal parts. So you can say each current will be what? This is 1 ampere and this is also 1 ampere. So we know the initial value of the inductor current, and initial value of the inductor current is 1 ampere. Keep this thing in mind. In which direction? In the same direction. So can I say here initial value of the inductor current IL0 minus is equivalent to 1. Now the switch is abruptly changed, and means the waveform is abruptly changed from 3 to 6. Now you are having 6 voltage as input to this. So let's take the Laplace transform of this circuit. So what circuit available to us at t greater than 0? What circuit is available at t greater than 0? This is 1. This is 6. 6 into ut you can say. This 1. What is this? 1. What is here? One inductor is available here. 1.5 Henry. And what else is available here? 1 ohm resistance is available. We are interested in this current I of t. Let's take the Laplace transform of this circuit. What is our ideal idea to solve the question? Take the Laplace transform of the circuit. So whenever we want to take the Laplace transform of circuit, we can take it. So what is the Laplace transform of 6? 6 by s, because it is activated for t greater than or equal to 0. So you can say the Laplace transform of the resistance is 1. This value is 6 divided by s. What is this resistance? This resistance is also having value of 1 ohm. What else we are having here? Else we are having is inductor. So how you write the inductor? Inductor will looks like this. Inductor is 1.5 Henry inductor and it is multiplied by s. So this you can say 1.5 into s. And in inductor we are drawing the voltage equivalent. So you can say here we are having minus plus L into I naught. And what is L? The value of L is 1.5 into 1. This is minus of 1.5. What else we are having? Here we are having 1 ohm resistance. This is our circuit. This is our circuit for what? This is our circuit for t greater than 0 in the Laplace domain. This is how circuit will looks like in the Laplace domain. Now we are interested in what? We are interested in the current in this direction. Current in this direction. I of, let me say this current is I of s. If this current is I of s, what is potential here? Potential drop here is I of s. Or let me redraw this circuit at the next so that we can approach it. Yes. We are having 1 here, 6 by s. This 1. This is also 1. Then we are having inductor. 1.5 s plus 1. Both are in series, so I can write this as a 1.5 and 1.5 s plus 1. correct? And what we can say, the current in this whole branch will be same. So if I am saying that this current is, let's say, I of S. If this current is I of S, what is potential across this point? 1 plus 1.5 S into I of S. So if this current is 1 plus 1.5 I of S, and this value is what? You can say the potential of this point is 1 plus 1.5 S into I of S minus 1.5. This node potential is given. If this node potential is given, we can directly find the value of I of S from here. So what is I of S? You can calculate like this. 1 plus 1.5 1 plus 1.5 S into I of S minus 1.5 divided by 1. This is the current in this branch going away. What is current in this branch? This current is I of S. And what is one more current we are having? One more current we are having is this potential minus this potential divided by resistance. So 1 plus 1.5 S into I of S minus 6 by S divided by how much? 1. The sum of all these three current is equivalent to 0. So you can calculate the value of Is from here, and when you calculate the inverse Laplace, you will have the exact value. But for solving the question, I can write the direct solution using time domain also. So for RL circuit and RC circuit, it is better to go with time domain. Otherwise, this calculation is required. But yes, we can use any of the method to solve. When you write answer using time domain method, it is very simple. What is the steady state current? The steady state current is what? This is short circuit, so 1 and 1 half plus 1 3 by 2. 6 divided by 3 by 2 is 4. 4 means this current is 2. So you can write directly. Steady state current is what? 2. Initial current is what? Initial current is 1. So 1 minus 2 into e to the power minus of t by tau. And what is tau? The L is equivalent to 1.5 and R equal to 1 plus 1, half plus 1, 3 by 2. So R is also equivalent to 1.5. So time constant is 1. So what is equation? 2 minus 1 into e to the power minus of t. Time domain method will give you easy solution, but you can do this also and can get the answer. Not difficult, means little bit lengthy but not difficult. Let's take few more questions. Okay. Okay, we are having one more question. There is no restriction which approach you will use, but we can solve this question very easily. What they are saying what is the value of ILT, the current across inductor. So how we can write the current across inductor? So what is initial condition of the switch? Initial condition switch is closed. If switch is closed means you are maintaining 0 volt across this branch. If you are maintaining 0 volt across this branch, 10 volt and 1 ohm. So can I say IL0 minus for the circuit is equivalent to what? 10 divided by 1 ampere. Why 10 divided by 1 ampere? This is 10 volt and there is no meaning of this branch, and this is 1 and this inductor will act as a short circuit. So initial current is equivalent to what? Initial current at t equal to 0 minus at t equal to 0 plus IL0 plus equal to 10 ampere. So either this option is correct or this option is correct. These two options are wrong. You can match the option also. Now, what is the steady state current? So can I say in a steady state, the switch is open. If switch is open, 10 volt is still connected. So what is the current? You can say the steady state current will be 10 volt plus 30 volt, 40 volt, 4 plus 1, 5. Steady state current is what? 40 divided by 5 is 8 ampere. So which option is correct here? This option is correct here. So you can write I of infinity, IL of t can be written as I of infinity plus 10 minus 8 is 2 into e to the power minus of t by tau. And this is which circuit? This is one RL circuit. What is RL's time constant for RL circuit? The time constant resistance is 5 and inductor is 0.5. So you can say inductor L equivalent is given by 0.5 Henry and R equivalent is given by how much? 5 ohm. So L by R 0.1. So if time constant is 0.1, what is the expression? 8 plus 2 into e to the power minus of 10t. So when you are having first order circuit, it is easier to apply the time domain approach. Okay, this is again one previous year question. What they are asking, in the circuit shown, the switch is closed for a long time. Okay, the switch is closed, then it is open. So when for t less than 0, how at t equal to 0 minus at steady state point, how our circuit will behave? This is 2 volt. This is one resistance. This is one resistance and this is one inductor and this is our circuit at IL0 minus. So applied voltage is 2 and resistance is what? 1, because there is no meaning of this 2 ohm resistance, because these 2 points are equipotential point and across equipotential point the current will be 0. So you can say IL0 minus equal to what? The current through this is 2 ampere. So when switch is open, the inductor will hold 2 ampere. So you can say this is your circuit now. At t greater than 0, the circuit is having this condition. This value is 1. No circuit is available in this direction. And this value is 2. And what is current you are having? Current you are having in this direction. And what is value of this current? 2 ampere. So this 2 ampere will enter into this. So this will be plus minus of 4 volt. But here they are asking with opposite polarity. So answer is what? Minus 4 volt. These are very easy question if they are asking the initial conditions. Okay. So this is our discussion on the transient networks. You can take this question as a homework. This is our discussion on the transient network. In next class, we will start the two-port networks and we'll try to analyze the two-port network, and two-port network with theorems we will analyze. Thank you very much.